The first important rule here is called as the sine rule, which states that in any triangle, the sides are proportional to the sines of their opposite angles. So that means A upon sine A is equal to B upon sine B is equal to C upon sine C. Now just to recollect the symbols, when we write A in lowercase, it means the side A, the length of side BC, which is denoted as small a. And when we refer to capital A, that means it's the angle. So therefore we are taking the sine of angle A, right? So that is what is the meaning of the term A upon sine A, right? Now let us see the proof of this particular sine rule. In proving the sine rule, we consider three different cases which refer to the three different types of triangles. In the first case, we are considering that the triangle is an acute angle triangle. That means all the angles are acute, they are less than 90. In the second case, the triangle is obtuse angle triangle. That means one of the angles, say C here in this case, is obtuse, that is bigger than 90. And in third case, angle C is a right angle, so that's a right angle triangle. Alright, now in the first two cases, we make a small construction, that is from vertex A, we drop a perpendicular D on the opposite side BC. Now we will observe that if we try to write the sine of angle B in terms of the altitude AD, right? So in the first figure, let's consider case 1. If we write sine B, that is nothing but AD upon AB, right? So if you consider the triangle ABD, in that case the opposite side to B is AD and the hypotenuse is AB. Now we know that AB is nothing but C, so therefore we can write AB as nothing but C, because this side is C. Now we can see that in the second case also we can write the same statement, that is sine of angle B is nothing but AD upon AB, which is nothing but C. And similarly we can write sine of B is equal to AD upon AB, which is nothing but C in the third case also. So basically the statement is true for all the cases, right? So cross multiplying, we get AD is equal to C sine B, which is an important step in proving the sine rule. This is our say statement number 1, right? Now coming back to the first case, we consider now the second triangle, that is the triangle on the right side, that is triangle ACD. So considering triangle ACD like this, let us try to write the value of sine C. So sine C is nothing but AD upon AC, and we know that AC is nothing but B, so that can be written as AD upon B. So therefore cross multiplying, we get AD is equal to B into sine C, correct? So this is the conclusion. Now let's see what happens for case 2. Now in case 2 we have the exterior angle of C, which is nothing but pi minus C, since it's a supplementary pair with angle C. So therefore sine of pi minus C is nothing but its opposite side, which is AD, upon the hypotenuse, which is AC, right? Now we know that sine of pi minus any angle is same as sine of the same angle, so that is sine C is equal to AD upon AC is nothing but B. So therefore on cross multiplying we get AD is equal to B into sine C. Now when we come to the third case, we have sine C is equal to, if you look at C is nothing but 90 degrees itself, so sine C is nothing but 1, right? Now we rewrite this one as AD upon AC, simply because AD and AC both are one and the same. So therefore we can write sine C is equal to AD upon B, giving us finally AD is equal to B sine C. So if you observe, in all the three cases we are once again getting the same statement, that is AD is equal to B sine C, no matter what type of triangle we consider. So therefore, summarizing that, we get AD is equal to B into sine C. This is our second statement. So therefore, from 1 and 2, we conclude that these two statements are true for any type of triangle. So therefore, we have B sine C is equal to C sine B, equating 1 and 2. And hence, taking the respective terms on other side, we have B upon sine B is equal to C upon sine C. Now we obtain this relation by taking BC as the side horizontally. Similarly, if we rotate the triangle, that is, if we take AB as the side on horizontal line, then we will get similar relation, and hence we can prove that the other ratio, that is A upon sine A, is also equal to each of the ratios shown here. So therefore finally we get the statement of sine rule, which is A upon sine A is equal to B upon sine B is equal to C upon sine C, which is a very important rule in solving a triangle. Now when we actually use the sine rule, we may often need to use slight variation. That is, here is the useful approach for using the sine rule. Now we know that A upon sine A is equal to B upon sine B, and that is equal to C upon sine C. Often we say that let each of this ratio be called as K, right? So therefore, cross multiplying, if you consider A sine A equal to K, then cross multiplying leads us to A is equal to K sine A. Similarly, B is equal to K sine B, and similarly C is equal to K sine C. So this K method is often helpful in proving certain types of statements, as we will see in the examples using the sine rule.